So in this video I'm going to explain about the next logical instruction, which is called as a XRI. So the meaning of this XRI is exclusive or immediate with accumulator. So the purpose of this instruction is here it will perform the exclusive OR operation of the 8-bit immediate data with the content of accumulator register, and after performing this XOR operation the result will be stored into the accumulator. So the opcode for this instruction is XRI, and their operand will be 8-bit data, because we are performing this XORing operation of this 8-bit size of the accumulator register. So that is the reason we have to take here the data also should be the similar size of the 8-bit. So now we can understand their operation with the example. So here, for example, we can write here as a XRI A to H. So for example, we can take here this data. We can take the data of this accumulator or the content of this accumulator as a 8FH, and this 8-bit of immediate data we are taking here as a to H. So now how the operation will perform here. So this accumulator content is 8FH, and this data here it has taken as a to H. So the binary pattern of this 8FH, it can be written 1000. Then for the F it is 4 times 1, and for this A2 it will be 1010, so that is 10 here, and for this 2 we can write it here 0010. So now, as I had explained in the previous video for this XOR operation, how it will perform when both the input are same, then their output will be 0. If both the inputs are different, then their output will be 1 here. So as a first stage, it is having the input 1 0. So their XOR operation output will be 1 here. From the second stage, that both the inputs are 1 and 1, it means it is same. So their output will be 0. Then from third stage it is 1 0, so their output will be 1. From the fourth stage 1 0, so their output will be 1. And from this fifth stage again it is same as like 0 0, so their output will be 0. Then again next it will be 1. Then again next will be 0, and here also it will be 0. So we will get it here. This is having the hex equivalent as a digit 2, and this is here D. So 8 plus 4, 12, 12 plus 1, it will be 13. So A means 10, B means 11, C means 12, and D means 13. So this will be here D. So after performing this XOR operation, the accumulator content here it will be 2DH. So this is the data whatever we had taken. It is before. This is here before, and here after the execution of this instruction, the data will be here as a accumulator content. It will become here as a 2DH, and data will be same as like whatever we had taken as a to H itself. So just after execution of this instruction, if you check it here, the content of the accumulator, then it will be having here A is equal to 2DH. And as like what I had explained for that XOR instruction, the effect of this instruction over the flags will be same. So here sign 0 parity will change as per the result, but this auxiliary carry and carry flag will be always fixed after execution of this instruction as a reset here. So carry, auxiliary carry, because we had seen even from the fourth stage or from the 8th stage, there cannot be any extra bit generated. So due to that reason, their auxiliary carry and carry will be reset for this instruction. So now here sign bit. So here if you'll see that this sign bit, it is here 0. So here this will be 0. Now the result is non-zero. It is here 2DH. So the result is non-zero. So that is the reason this zero flag will be zero itself. And for the parity flag, what will be happening? So we have to count number of ones in this result. So in this result, if you will count that number of ones, it is 4. So 4 is even number. So it is performing here even parity. So due to that reason, this parity bit will be 1 here. So we got it here. Sign flag will be 0, 0 flag will be 0, parity flag will be 1, and carry, auxiliary carry both will be here as a reset. That means 0 and 0. So now this is the main important part whatever I had given for this flag. So we'll write here in the note also. In the note we can write down here that sign 0 parity flags will altered to reflect the result. But this auxiliary carry will be 0 and carry will be 0 irrespective of this result obtained here. So that is the main key point here. You must have to remember this. Now we'll check it about their size, machine cycle and T states. So as we had seen that this instruction is having XRI A to H. So this XRI is called the first byte and this A2 is called the data here. So that is the second byte as a operand. So here the size in terms of byte, it will be 2 byte here. Now we'll talk about that their machine cycle. So here as a by default we know that for all the instruction the first byte will be opcode fetch. So this XRI is giving here the opcode for this instruction. So the first machine cycle by default it will be opcode fetch. Then the second byte will be the operand of this instruction as a to H, which is outside of the processor. It means before execution of this instruction it must be stored into the memory chip. So while execution of this instruction, that microprocessor will take that opcode fetching first, and after decoding and execution of this opcode fetch, microprocessor is knowing that the second byte will be operand for this instruction. So that is going to be taken from the memory to processor. So the second machine cycle for this instruction will be what? That will be memory read. So reading for this A to H is called as a memory read. So the second machine cycle is here as a memory read. So total number of machine cycle to execute this instruction will be 2 machine cycle. So as we know that for this opcode fetch by default it is required 4 T state, and for the memory read by default it is required 3 T state. So the total number of T states for the execution of this instruction will be 4 plus 3, so that is here 7 T states. So here that first of all you know about the operation of this XOR, and after then how this instruction works, then what is their impact over the flags. So the major part is here that you need to keep in mind that auxiliary carry and carry will be always reset for this instruction after execution of this instruction, and remaining sign 0 parity will change as per the result obtained after this execution of this instruction, or we can say that after operation of this instruction what will be the result. Accordingly sign 0 parity flag will altered. So I hope you understand this instruction with much of clarity. Thank you.